Integrating indefinite integrals. The reason why it's indefinite is because it's not bounded by any points. And we know that because there's no numbers at the top or bottom of this integral sign here. So for this we'll be finding an expression rather than a numerical value. So how do we integrate? If we have, for instance, the integral of x to the n being a number, then what you have to do is add 1 to the power, so x to the n plus 1, and then divide that whole expression by the new power. You may also write it like this, so 1 over n plus 1 times x to the n plus 1. Applying it to this question, we have the integral of 3x to the 4 with respect to x. Firstly, we want to raise the power by 1, so we'll have 3x to the 5, because 4 plus 1 is 5, and then we're going to divide it by the new power, which is 5. Now one extra element you need is plus c. C is a constant, a numerical value. We have this because when you differentiate an expression, a standalone numerical value will differentiate out. It will cancel out. So when we integrate, we have to acknowledge that there may have been a constant there. However, we cannot figure out what the constant was. There's a video explaining this further in the link below. At this point then, we've got our final answer. We've integrated 3x to the 4 and we've got 3x to the 5 over 5 plus c. Second question, we've got 3x squared minus 28x to the 6. Now we've got two terms to the equation here. We've got 3x squared and minus 28x to the 6. So we can integrate these individually. So firstly integrating 3x squared, we'll have 3x to the power plus 1, so 2 plus 1, which is 3, all over 3. Then the minus 28x to the 6, we'll have minus 28x, add 1 to the power is 7, then all over the new power, which is 7. And then not forgetting the plus c at the end, for the constant we don't know. Now we want to tidy this up a bit, because we can simplify it further, so 3x cubed over 3 can simplify to x cubed. Then the second term, 28 divided by 7 is 4, so we can have minus 4x to the 7 plus c. So we've got our equation integrated fully now. 3 questions for you to try. Pause the video and resume when you're ready to see the answers. For our walkthrough of these answers, there's a link in the video at the end and in the description below. Let's take this up a notch now by getting other functions involved. The first question, we want to integrate cos x with respect to x. Because we're integrating cos x, we need to use the table of derivatives. Now because we're integrating, we're in essence going backwards. So rather than using the derivative table this way, which we do when differentiating, well actually technically we have the derivative, so we want to integrate by going this way. So to integrate cos x, I'm going to look where cos x is on the derivative side, which is here. And then I'm going to look what it would integrate to, which is sin x. So cos x will integrate to sin x plus c. Remembering the plus c because there may have been a constant that we don't know what it was originally. The second integral, we've got minus 4 sin x with respect to x. Be aware of this one because the function of sine only has x and no coefficient of x. So we've got sin x, we're actually looking at this one here. So I'm going to highlight this, I'm going to go backwards, and because it's a minus sign and that's going to a positive, it's actually going to become positive 4 cos x plus c. The reason why we've not got 4 here is because in essence it was 1x to begin with, so if we times the front by 1 it would still be 4. So our final answer is 4 cos x plus c. Little bit trickier now. The first one, we've got sin 3x with respect to x. I'm going to look where sine of kx is on the derivative side of the table. That's the right hand side, and that's here. So we'll be looking to go backwards again. Let's do it a bit at a time. Well, the sign changes, so this is going to become a minus. Sine changes to cos, so we've got cos. 3x in the cos function stays the same, so we've got 3x. Then looking at this constant in terms of k, well, if this constant multiplies by the whole thing, if we're going backwards, we're going to have to divide the whole function by k. So this will be divided by 3, so 1 over 3. So we've got minus a third cos 3x plus c. The second one, we can break it down in 2 parts because we've got this term and another term. So we've got 2 independent terms. 1 over x, we'll have a look at the derivative table, On the right hand side, we've got 1 over x here. Technically, we've got 1 over x here, but we don't know which one's which, so we'll just assume it's the first one. This integrates to ln x, so we can write that down. And the second part, we've got cos with a coefficient of x. So we're going to be looking at this one here. Well, as we integrate, the sign stays the same, so we can keep it as a minus. It changes from cos to sine, so we'll currently have 12 sine 4x. But because from here to here, we multiplied by the coefficient, we're going to have to divide by this coefficient here. So we'll have 12 over 4 plus c. So we'll simplify it, so we'll have ln x minus 3 sine 4x plus c. There's the final answer. 4 more questions for you to try now. Pause the video and again resume when you're ready to see the answers. As before, if you want to see the walkthrough of these answers being worked out, check out the link at the end of this video and in the description below. Check out the next video, which is definite integrals. Like, subscribe and support the channel, and I'll see you in the next video.